All right, so continuing on naming ionic compounds. So we took a look at group 1 and 2 and then aluminum, but what about all of our transition metals? So remember, our transition metals and even our post-transition metals are down here, and they can have variable charge, right? But they're still metals, and so when they react with non-metals over here, they'll still form ionic compounds, but we have to be a bit more careful when it comes to naming them because they can have variable charges. And so the naming structure goes here, the name of the transition metal or the post-transition metal. And then in parentheses, we put the charge of the transition metal in Roman numerals. And then after that, we add the name of the anion or the nonmetal. Add the "-ide" in there. And of course, if it's a polyatomic ion, we do not add the "-ide". So let's take a look at that. So we have FeCl3 and FeCl2. So you can tell that they are different compounds. So calling this iron chloride is simply not good enough, right? It doesn't give enough detail. So let's take a look at these components, right? One has 2 chlorines, one has 3. If we take a look at our periodic table, we see chlorine is over here, 1 away from the noble gases. So it's going to want a charge of -1. And so overall, this is going to be -3 because there's 3 of them. And then this is going to be -2. Which means that the charge on this iron is going to be a +3 because overall it must be neutral, which means this one's going to be a +2. And so that's what we put in the Roman numerals here, is this charge. So this top one here is iron 3, 1, 2, 3 chloride, whereas this bottom one is going to be iron 2 chloride. So the stuff in the Roman numerals is the charge on the transition metal, not how many of either things there are. So don't get confused by that. Let's take another look at example, Hg2O versus HgO. So Hg is mercury. So let's go ahead and find this on the periodic table. It's right over here, right? It's a transition metal, so it can have variable charge. The O is oxygen. Oxygen is going to take a -2 charge. So this is -2, this is -2. So then you have to think about what's going to be the charge on the mercury, right? And overall, it must be neutral. So if we have 2 mercuries and it has to sum to +2 to cancel out the -2, they must each be +1. Whereas this mercury, when there's only 1 of them, this one's +2. So the top one would be mercury 1 oxide, whereas the bottom one would be mercury 2 oxide. So again, the stuff in the Roman numerals is the charge of the transition metal. Take a look at another one of these. Let me write this stuff out and then go ahead, pause the video and try to figure it out. All right, go ahead, pause the video and figure these out. Cool, so hopefully you've paused the video and figured these out. SO4 is a polyatomic ion with a -2 charge, and there's 3 of them. So overall, this side is a -6 charge. That has to be balanced out by the irons, and since there's 2 of them, each iron has to be a +3 charge. And so this is known as iron 3 sulfate. Here we have tin. If you look at the periodic table, tin's a little funky one. Its symbol is SN. So tin 2 fluoride, think about what that means. The 2 is the charge on the tin. So this is tin 2+. If we think about fluorine, it's a halogen, so it's going to want a charge of -1, so it's just going to be F minus, right? And so then you have to think about balancing the charges out. If the tin is 2 plus and the fluoride is a -1, how many fluorides do you need? Well, you need 2. So this will be SnF2. Next up, we have tin 4. So that means that the tin has a charge of +4. Each fluoride has a charge of -1. If you're thinking of how you're going to balance them out, you're going to need 4 fluorines for each tin. So it'll be SnF4. So get familiar with that nomenclature. And if there isn't enough already, it gets a little bit more interesting. Sometimes there's water bound to ionic compounds. And we need to symbolize that. So for example, copper sulfate, copper 2 sulfate could be like that. And then there could be some waters not directly bonded to the compound, but just kind of hanging around. And so the way this is shown is it gets this fat dot and then however many waters there are. So in this case, there's 5 of them, and then water's H2O, so 5H2O. So the name of this guy would be copper 2, because the sulfate is 2 minus, sulfate, and then for the waters, we say pentahydrate. So the hydrate just means some waters. And then the prefix, it depends how many water there are. For 5, it's penta. The prefixes are for 1 water. We just say hydrate. So no prefix. For 2 waters, we say dihydrate. 3 is going to be trihydrate. 4 is going to be tetra. 5 is going to be penta. 6 is going to be hexa. 7 is going to be hepta. 8 is going to be octa. 9 is going to be nona. And then 10 is going to be deca. So unfortunately, you just kind of have to memorize these things. So get familiar with naming ionic compounds, both with fixed charge metals and these variable charge metals as well.